When NASA finally held its long-anticipated press briefing to unveil the complete set of new 3I Atlas images, I listened with more attention than usual, not just to the statements they made, but to the ones they carefully avoided. They displayed the latest SOHO smudges, some faint Lucy detections, a diffuse halo from Maven, and the familiar tear-shaped Hubble silhouette we've all examined for months. But throughout the entire 45-minute presentation, something deeply odd happened. They never once addressed the single feature of 3I Atlas that should have dominated the discussion. They never talked about its size, not briefly, not as a caveat, not even as a passing remark. And that silence, more than any blurry image NASA revealed, is the most astonishing part of the event. Because when we analyze an interstellar visitor, size is not a trivial parameter. It is the bedrock that every other calculation rests upon. How much material escapes? How fast does vapor flow? How dense is the nucleus? How should sunlight affect it? How quickly should it spin? How should it accelerate under its own jets? How many active vents can it sustain? How long could it survive its solar approach? Every one of these depends on the object's scale, yet NASA avoided the subject entirely. But from the available data, the Webb infrared constraints, the Maven hydrogen cloud, the high-rise brightness distribution, the dust scattering ratios, 3I Atlas appears to be enormous. Even a cautious estimate places it around 5 kilometers across, possibly larger. This is not a minor deviation, it is a radical anomaly. To appreciate how extreme this is, consider the comparison. Oumuamua was roughly 100 meters, Borisov was about 1 kilometer, 3I Atlas appears to be 5 kilometers or more. That means 3I Atlas is 1,000 times more massive than Borisov and 1,000,000 times more massive than Oumuamua. We have observed only 3 interstellar objects. Logically, there should be a distribution, many small, some medium, almost no giants, yet the third one we find is the largest by a factor of 1,000,000. Statistically, that is absurd. It contradicts every expectation of random sampling from interstellar debris. If you roll the die, you would expect all numbers repeatedly, long before rolling a 6 1,000 times consecutively, yet that is essentially what happened with 3I Atlas, and this is why the size is not a detail, it is the central puzzle. Probabilistically speaking, if interstellar space is filled with fragments of planets, comets, asteroids, and icy debris, the smallest bodies should dominate. They are easier to eject, more common, more likely to drift across star systems, but 3I Atlas violates this expectation violently. Imagine holding out your hand in the rain. The first 2 droplets are tiny and soft, and the third is an entire iceberg. Would you call that normal, or would you question the sky itself? Because ejecting a 5-kilometer object requires staggering amounts of gravitational energy. Planetary scattering could do it, but only with a very specific architecture. A binary star system might eject such a giant, but the mass balance must be perfect. A planetary collision might launch a fragment, but the geometry must be nearly ideal. Every scenario leads to the same conclusion: it is extraordinarily rare, which means 3I Atlas either originated in an exceptionally unusual environment, or it was created by an extreme catastrophic event, or it represents a mechanism we do not yet recognize. Yet NASA simply skipped the topic. What the public received was a patchwork of images, many fuzzy, many incomplete, many lacking context. A pixelated SOHO smear, a faint ultraviolet glow in Maven, a dust cloud from High-Rise, a sideways plume from Punch, a thermal blot from Spherex, a few scattered points on a Webb plot, a Hubble shell of dust. Interesting, yes. Informative, no. None of these answer the fundamental questions. None explain how such a massive object found its way into our solar system. None address the statistical impossibility, and none mention the size. None explain how such a massive object found its way into our solar system. None address the statistical impossibility, and none mention the size. Another detail NASA avoided is the improbability of 3I Atlas's trajectory. It arrived almost perfectly aligned with the planetary plane, a configuration that allowed Hubble, JWST, SOHO, Stereo, Lucy, MRO, Maven, Punch, and even surface rovers to observe it. But this geometry is incredibly rare. Roughly 1 in 500 interstellar visitors should naturally follow such a convenient path. NASA treated this as luck, but the scientific response should be, why this object and why now? Ignoring an anomaly does not make it disappear. Nearly every breakthrough in science began with something that did not fit. Mercury's orbit rejected Newton until Einstein answered. The ultraviolet catastrophe broke classical physics until Planck intervened. The photoelectric effect contradicted Maxwell until quantum mechanics arrived. Galactic rotation defied expectations until dark matter was introduced. Every anomaly was a doorway, not an inconvenience. And 3I Atlas contains multiple anomalies. Its enormous size, its nickel-rich iron-poor chemistry, its unusually tight jet collimation, its improbable alignment, its excessive outgassing far from the sun, its inconsistent brightness across wavelengths, its strange dust dynamics, its rotating jets that refuse to curve, the size alone strains our understanding. Combined with everything else, the object becomes a profound mystery. Yet NASA avoided these entirely. To be fair, I do not believe NASA is hiding anything. NASA is a bureaucracy. Bureaucracies prefer safe conclusions. They avoid risk. They avoid speculation. They avoid statements that might spark confusion or controversy. And the size of 3I Atlas leads directly into controversy, because acknowledging it means acknowledging that our models are insufficient. But discomfort is how progress begins. One of the strangest properties of 3I Atlas is its chemistry. We've detected nickel but almost no iron. This is extremely unusual. Nickel and iron form together inside stars. Every comet, meteor, asteroid, or planetary fragment we've studied contains more iron than nickel. The only materials on Earth with high nickel and very little iron are advanced aerospace alloys. I am not claiming 3I Atlas is artificial, only that this chemistry, combined with the size, the jets, the trajectory, and the mass, requires open-minded investigation. NASA did not mention the nickel anomaly, nor did they connect it with the size anomaly, but these features are not isolated. Together they form a picture, and that picture is anything but simple. Based on current data, 3I Atlas rotates every 16 hours. If that is correct, its jets should wobble or spiral, but they don't. They remain straight, narrow, precisely aligned, as though sculpted by invisible nozzles. This contradicts typical comet behavior. A large, slowly rotating body should have wide arcing jets, yet 3I Atlas does the opposite. This is why jet collimation was one of the anomalies I emphasized. NASA did not mention it. Let me repeat, I am not saying 3I Atlas is artificial. I am saying it is not understood. If natural, then the processes that formed it are unlike anything currently in our catalog. Possible origins include a shattered volatile moon, a massive Kuiper belt analog, a mini Neptune stripped of its outer layers, a planetary mantle fragment, a tidal disruption event, a collision chain in a dense binary star system. Each scenario is rare, but the size alone forces us to consider them, and the best observations are still ahead. On December 19th, 3I Atlas will reach its closest approach to Earth. At that moment, Hubble JWST, ground arrays, infrared systems, radio telescopes, and observatories worldwide will lock onto it. We may finally measure the nucleus directly. We may resolve the jets in fine detail. We may identify exotic molecules. We may detect a rotational signature. We may witness fragmentation. We may discover physics we did not expect. But no matter what we learn, the size anomaly remains the core mystery. Ignore it, and we risk ignoring the truth. In science, certainty is the enemy of learning. 3I Atlas is not a threat, not a crisis, not a danger. It is a messenger, a rare visitor from another system, carrying knowledge about environments far beyond our own. But for this object to fulfill its purpose, we must ask the questions NASA avoided. Because the size is not just a metric, it is the key, one that may fundamentally reshape our understanding of interstellar geology, planetary formation, and cosmic evolution.